everyone, welcome back to the Introduction to Data Science using Python series with Shambhavi. Today, we're diving into an exciting topic, that is applications of neural networks using Python. Neural networks are at the heart of modern AI, powering everything from image recognition to voice assistance. In this video, I'll walk you through the concepts, applications, and Python code examples to show you how neural networks work in action. So, without any further delay, let's get started. So, what are neural networks? Think of them as computer systems that mimic how the human brain works. They consist of layers of interconnected nodes or neurons that process data, learn patterns, and make predictions. Neural networks are the foundation of deep learning, which is widely used in tasks like image classification, natural language processing, and even self driving cars. In this video, we'll be focusing on the image classification application using the MNIST dataset. We'll also write the Python code to demonstrate these applications using libraries like TensorFlow and Keras. Working of a neural network. Before we dive into coding, let's first understand the workflow of neural networks. Neural networks learn from the data through the following steps. Input layer. The data enters the network through the input layer. For example, in image classification, each pixel of an image is an input. Hidden layers. The network processes the inputs through one or more hidden layers. Each layer contains neurons, which apply weights and biases to the input data, followed by an activation function. The activation function introduces nonlinearity, enabling the network to learn complex patterns. Output layer. The final layer provides the output. For classification tasks, this could be probabilities for each class. For regression, it's a continuous value like a price or a score. Training. During training, the network learns by comparing its predictions to the actual results using a loss function. It adjusts the weights and biases through an optimization algorithm, typically gradient descent, to minimize the loss. Evaluation and prediction. Once trained, the model is tested on unseen data to evaluate its performance. It can then make predictions on new data. This workflow is what makes neural networks so powerful. They continuously learn and improve with data. Now, let's apply this workflow to an actual problem, that is image classification using the MNIST dataset. MNIST contains 28 by 28 pixel grayscale images of handwritten digits, and our job is to classify them into 10 categories, that is from 0 to 9. Here's how we can implement this in Python using TensorFlow and Keras. Here, the flattened layer converts the 28 by 28 pixel matrix into a single vector. The hidden layer has 128 neurons, each applying a ReLU activation function, while the output layer uses softmax to assign probabilities to the 10 classes. After training, the model achieves impressive accuracy on the test set, showing it has successfully learned to classify handwritten digits. Now, let's look at the output of our image classification model. After training the neural network for 5 epochs, we evaluated it on the test dataset. Here's what we got. Test loss. This measures how well the model performed on the test set. A lower loss means the model is making better predictions. Test accuracy. This tells us the percentage of correctly classified images. In this case, the accuracy is around 98%, which means the model correctly classified 98 out of every 100 written digits in the test dataset. This high accuracy shows that our model has successfully learned the patterns in the MNIST dataset and is generalizing well to unseen data. Let's summarize what we learned today. Neural networks mimic the human brain and learn from data through layers of interconnected neurons. In our image classification example, we used a neural network to classify handwritten digits with high accuracy. Neural networks are revolutionizing industries, and I hope this video inspires you to explore them further. If you enjoyed this video, please like, share, and subscribe to Shambhavi Manjrekar. Let me know in the comment section if you'd like me to cover advanced neural network techniques or other AI topics. Thanks for watching, and I'll see you in the next video.